In this video, we'll be discussing the absolute extrema of functions and how to find them. The mean value theorem, the second part of lesson 4-1, will be covered in a separate video. The candidate test is used to find the absolute extrema of a function, the absolute maxima, the absolute minima, also known as the global maximum and the global minimum. Here are some brief definitions. You should have seen these before in the pre-calculus class, but if not, this should catch you up. The absolute maximum is the y value that is greater than or equal to all the other y values. It's also known as the global maximum. The absolute minimum, also known as the global minimum, is a y value that's less than or equal to all the other y values in the function. A relative maximum is a y value that's greater than or equal to all the nearby y values. A relative minimum is a y value that's less than or equal to all the other nearby y values. Extrema will be either the maxima or minimum values. We just thought of a word that refers to both. Critical numbers are x values at which f of x exists, but f prime of x is either 0 or undefined. So it's important to notice that all of these other ones, almost everything on this page refers to y values. When you are asked for absolute extrema or even relative extrema, you should assume you are being asked to provide a y value unless otherwise noted. This is in contrast to critical numbers, which are x values at which f of x exists, but f prime is either 0 or undefined. So the critical numbers will be useful to find the relative maximum and minima. This is what we will discuss in lesson 4-2. Briefly, a relative maxima would look like the peak of a hill, whereas a relative minima would look like the bottom of a valley. Critical numbers will be key to finding those two because, as you might be able to tell, if f prime of x is 0, that means it's a horizontal tangent line because we're talking about the slope equals 0, and we'd be at the valley. We could also look like this, in which case or like that, in which case we have a sharp turn, so f prime is undefined. The candidate test, or extreme value theorem, is very simple. We're going to start by finding the critical numbers because that will help us find the possible maxes and mins of the function, relative maxes and mins. Then we're going to find the y values at each critical number and at the endpoints of the interval. We pick the biggest or the least y value, and that will be known as the absolute extrema, meaning the least will be the absolute minima and the greatest will be the absolute maxima. Absolute extrema can occur at either critical numbers or endpoints. This is a special fact that AP really likes you to state whenever you do a candidate test on the AP test. It's very typical that on a free response question you will be asked to find an absolute maximum and minimum, in which case you should state that this can only happen at critical numbers or endpoints. Relative extrema, as I just mentioned, can only occur at critical numbers. Endpoint extrema won't be considered to be relative extrema in this course. That's, again, so relative extrema can only occur at critical numbers. That's why they have to be part of the candidate test. I found it useful to draw some pictures now about the types of functions we can see. So our most basic example would be like a line. This line has an absolute minimum on the left, an absolute maximum on the right. These occur at the endpoints for the function, and we see no rel extrema. Another type of function, a simple type of function that we've gotten used to, is a parabola type shape, in which case the absolute maximum happens to be an endpoint, happens to be a relative maxima, The absolute minima happens to be an endpoint. That's what I meant to say earlier. It's not a relative one. And this other endpoint is just nothing. We could also imagine a more complicated function in which the absolute maximum and the absolute minimum are both relative, also relative minima, and that's also a relative max, and the endpoints aren't doing anything. And we also have other relative mins and maxes that we have to throw out. So those are the types of things that can happen, and that's why pictorially we have to be able to consider the endpoints, because both endpoints could be important. One endpoint could be important, or neither endpoint can be important. But it's not possible to draw a picture where neither endpoint nor a relative extrema could be the highest or lowest point of the function. So here's an actual example of a picture type problem. What is the absolute maximum value of f? So I go back to the definition and I say, which y value is bigger than or equal to all the other y values? And if we inspect this graph carefully, we see that that y value is right here. This point is the only point with the highest y value. So I would say the absolute maximum value is 4. Where does this y value, at what x value does this f have an absolute max? That would be when x equals -4. And I'll usually try to be specific about what I'm talking about. X equals -4. They asked me for an x value. Absolute maximum, I decided not to. Absolute maximum point, easy to say. Now we have an x value and we have a y value. There's only one point. We could have several, which are both absolute maximums. In this case, we only have one absolute maximum. Absolute minimum. So now we are looking for the lowest possible y value. The most common student response here is that the absolute minimum y value, the lowest y value, is -2. However, this is a common mistake. This is not possible. We do not actually attain a value of -2. So we think, what else could be a candidate? Another common response is +1. These 3 points are all pretty low, and they are all at a height of +1. However, simple inspection of the graph would show a variety of y values that are lower than +1. Specifically, 0, this x-intercept, but we can go lower than that here. We can go lower than that here. We can continue this process of finding lower y values up to, but not including -2. So because this graph has thrown out what should have been its absolute minimum, is one way to think about it, there is no absolute minimum. It's due to this hole. If it was a filled-in hole, this would be an absolute minimum. So quickly going back to the pictures, I suppose we could add one where it's a line with both endpoints missing. So this one has no abs extrema, nor does it have any relative extrema either. It's just a line with no endpoints. At what x values does f have a relative minima? Now we're going to address more what we mean by nearby. So we usually talked about how it could be smooth, but it could also be sharp. Let's look. So I look for y values that are lower than all the y values nearby. This one is certainly lower. No matter which way I go from this point, I have to increase my y value. So I will say x equals -3 would be the first one I saw. Now I trace the graph, we're going up clearly. That's an interesting point. Down. This point, this cusp type shape, will be another one where I cannot do anything other than increase my y value. If I go a little to the right, I have to follow the line up. If I go a little to the left, I have to follow the line up. So even though the graph is not differentiable at this point, we still have a relative extrema. Now we go a little bit here, and here's another really weird situation. Most students assume that this has to be a relative maxima because the location of the hole would suggest a relative maxima. However, this is a relative minima. The y value when x equals 2 is 1. If I go a little to the right, my y value is bigger than 1. If I go even a little bit to the left, my y value is larger than 1. So no matter which way I go, if I'm going to stay on the graph, I would increase my y value. So 2 must be included as a relative minima. As I say, this is very upsetting to students. A common question at this point might be, well, what if there were no dot? Then this would not be a relative max, nor would it be a relative min. Following up, what if the dot was up here? Then, of course, this would be a relative maximum by the same argument we use to show that the actual point is a relative minimum. Meaning if I go a little bit to the left, I have to decrease my y value. If I go a little bit to the right, I have to decrease my y value. However, with the situation as presented, we have what must be a relative minimum. Finally, relative maxima here. X equals -1 is the only relative maxima. Again, resist the temptation to call this a relative max. This is a hole. This is a phantom point. That's going to be it for the basics. The next video will address how to find a global extrema analytically. Go ahead and try problems 1 through 4, A through D, on page 66 in your textbook. I'm sorry, I was on the wrong page. Try problems 1 through 4 on page 63 of your textbook. Have fun with those. Have a nice day. Good luck. Bye for now.